the biggest supply of recycled steel in the world doesn't actually come from underground mines. So where does it begin? Surprisingly, it starts in the auto recycling industry, often described as a car's second gateway. Every year, this industry sends an enormous stream of recycled steel back into the global market. In the United States alone, more than 12 million vehicles reach the end of their lives and are taken apart for recycling. This process effectively turns scrapyards into some of the most productive steel sources humans have ever created. A vehicle that once seemed finished with its purpose is actually just beginning another journey. In this video, we'll explore how worn-out cars are transformed into essential raw materials used in construction, manufacturing, and even the production of future automobiles. Imagine buying a car for $48,000. After spending 10 years on the road, how much value could it possibly have left once it's sent to be recycled? The answer leads us to an industry worth nearly $60 billion every year. Millions of retired vehicles are dismantled, compressed, and processed into valuable materials that return to the production cycle. This system supports hundreds of thousands of jobs, dramatically lowers the cost of producing new metals, and significantly reduces environmental impact. If traditional iron ore deposits are natural mines, then end-of-life vehicles can be thought of as limitless man-made mines. Recycling steel saves enormous amounts of energy, up to 74% compared with producing metal from newly mined ore. On average, about 75% of a vehicle's total weight can be recovered, including steel, aluminum, glass, and plastics. Because of this, hundreds of millions of tons of material are brought back into circulation every year, beginning a new life as buildings, everyday consumer goods, and even the next generation of vehicles. When a car finally reaches the end of its lifespan, it first arrives at the intake area of a recycling facility. Here, trained technicians begin a detailed inspection process. They document the vehicle identification number, engine serial number, year of manufacture, general condition, and all related paperwork. Photos of the vehicle are taken, a tracking tag is attached, and all the collected information is uploaded into a digital management system. This careful documentation ensures that every stage of the recycling process can be monitored, while also helping specialists estimate the remaining value of the vehicle before dismantling begins. During the inspection phase, technicians pay close attention to parts that may still have value. Major components such as the engine, transmission, electronic systems, and interior elements are carefully evaluated. Any parts that remain functional are removed and redirected to the enormous used auto parts market, an industry worth billions of dollars each year. Vehicles that are too damaged or completely worn out, however, are sent directly to the dismantling line, where their materials will be recovered instead. Once the inspection stage is finished, the cars are arranged throughout the yard in organized rows, waiting their turn to move through the processing system in a precise and orderly sequence. What many people don't realize is that in the United States, more than 95% of vehicles that reach the end of their lives eventually pass through this recycling network. That statistic makes automobiles the most recycled consumer product on the planet. Because of this highly structured process, nearly every car is able to deliver as much recoverable value as possible back into the economy. Once intake and inspection are complete, the vehicle is transferred to the main processing area. The very first task is removing the battery, which remains the most significant electrical hazard inside the car. In traditional gasoline-powered vehicles, the lead-acid battery is taken out right away. These batteries have an extremely high recycling rate, over 98%, because nearly every component inside them can be recovered. The lead, plastic casing, and even the sulfuric acid can all be reused to manufacture new batteries. Hybrid and electric vehicles require an even more cautious approach. Their much larger lithium-ion battery packs contain far greater energy and must be handled under strict safety procedures. Technicians carefully disconnect these units, seal them in protective packaging, and send them to specialized facilities designed to recycle high-voltage batteries. Only after the entire electrical system has been safely removed can the vehicle move on to the next phase of dismantling. With the battery out of the way, the car is lifted onto a service platform where technicians begin extracting all remaining fluids. This includes gasoline, engine oil, transmission fluid, brake fluid, coolant, and even the refrigerant used in the air conditioning system. Heavy hydraulic clamps lock the vehicle firmly in place while a reinforced steel probe punctures the fuel tank and connects to a powerful vacuum system. Despite being retired, the average vehicle still holds several gallons of fuel and other liquids, enough to create serious fire hazards, explosions, or environmental contamination if handled improperly. Within just a few minutes, these fluids are completely drained and safely routed into sealed underground storage tanks. One of the most impressive aspects of this stage is that almost nothing is wasted. After being filtered and cleaned, a large portion of the recovered fluids is reused right inside the facility. They help power forklifts, generators, and other machinery that keep the plant running. Any remaining liquids are stored for internal use, helping the operation significantly reduce its overall energy expenses. To maintain safety during this process, the system operates as a completely sealed circuit. Pressure sensors, one-way valves, and secure caps ensure that no vapors escape into the air, protecting both workers and the environment while keeping the entire line running smoothly. Once every drop of fluid has been removed, the vehicle advances to the next phase, taking apart its major components. The wheels are typically the first parts to come off. They occupy a large amount of space and are relatively quick to remove, making them an ideal starting point. Tires, however, present a unique challenge. If sent to landfills, they can take decades to break down. Instead of being discarded, most used tires are shredded into small rubber granules that are later used in asphalt for road construction or as cushioning material for playground surfaces. Some are even burned as an alternative energy source in large industrial furnaces. Meanwhile, the metal rims, whether steel or aluminum, are separated and sent directly to metal smelters where they will be melted down and recycled. After the wheels are removed, technicians move on to the glass components. Windshields and windows are carefully cut out using specialized tools. These panels are made from laminated glass reinforced with a layer of PVB, a plastic film that prevents the glass from shattering into dangerous fragments. Recycling facilities are able to recover not only the glass itself but also the PVB layer. This material is often reused in sound insulation products and various industrial coatings. Next, the doors are taken off. At first glance, a door might seem simple, but it actually contains a complex mix of materials. The outer steel or aluminum frame is separated and prepared for melting, while the internal mechanisms, such as electric window motors, locking systems, and wiring, are dismantled individually to recover copper, plastics, and small magnetic components. Finally, the interior of the vehicle is stripped out. Seats, dashboards, carpets, and other cabin materials are carefully removed and sorted. Electrical wiring is often stripped to extract valuable copper, while plastic panels and fabrics are shredded and processed so they can be transformed into new recycled materials. The final major components to be removed are the engine and transmission, the heaviest and most valuable mechanical systems in the entire vehicle. Some of these units are still in good enough condition to be refurbished and sold again in the used parts market. Others are dismantled further so valuable materials can be recovered, including aluminum, steel, copper, and even precious metals found inside catalytic converters. This carefully organized dismantling process ensures that every possible component is recovered for value. At the same time, it prepares the vehicle for the next major stage, crushing the remaining frame safely and efficiently. Before a car is fed into the crusher, however, it still contains various non-metal components that could interfere with processing. These include items like bent exhaust pipes, large plastic panels, and bundles of tangled wiring. To deal with these leftover materials, the vehicle is moved to a rough processing zone where powerful mechanical arms take over. These machines are equipped with hydraulic shears designed to handle heavy-duty work. With clamping forces that can reach tens of tons, the massive steel jaws tear away any remaining doors, rip out exhaust systems, and crush radiators within seconds. Materials such as plastic panels, foam insulation, and other non-smeltable components are immediately separated and discarded. The incredible mechanical force of these machines allows the vehicle's frame to be cleaned far more quickly than any manual dismantling could achieve. This stage essentially works as a coarse filtration step for the entire recycling line. It removes materials that might catch fire, contaminate the recycled metal, or potentially damage the crusher itself. After just a few minutes under the hydraulic shears, the vehicle is reduced to a clean shell made primarily of steel and aluminum, ready for the next step. Once the frame has been stripped down, it is transferred to a massive hydraulic press. Here, crushing forces ranging from 150 to 200 tons squeeze the structure, often more than 4 meters long, into a compact block of metal. The car's volume is reduced to roughly 1/10 of its original size. Depending on the equipment used, this compression stage can be performed using several different machines, each designed for a specific purpose. One common option is the car baler, which compresses the vehicle frame into a dense, cube-shaped block of steel known as a bale. These tightly packed bundles are much easier to stack, store, and transport. Modern industrial balers can process between 25 and 40 vehicles every hour, making them ideal for large recycling facilities that must handle massive volumes of scrap before the shredding stage. Another machine commonly used in recycling yards is the car flattener, which is especially popular in small to mid-sized scrap yards. Instead of compressing the vehicle into a cube, this machine presses it into a flat sheet of metal only a few dozen centimeters thick. Its main advantages are speed, lower power consumption, and a smaller investment cost compared with larger industrial equipment. However, there is a trade-off. Because flattened cars are not packed as tightly as compressed bales, they have a lower metal density. As a result, the shredding process that follows often requires more energy to break them apart. There is also another type of machine known as the shear baler. This device performs two tasks at once, compressing the vehicle while also cutting it into smaller, manageable sections. Although this system processes fewer vehicles per hour, it provides a more direct route to the next stage. In some facilities, these chopped sections can move straight into shredders, or even directly into smelting furnaces, eliminating the need for a separate baling step. To put it simply, each method has its own role. Baling is like tightly packing items into a box for storage. Flattening is similar to rolling something thin to make transportation easier. And shearing is like chopping materials into ready-to-use pieces for melting. Different techniques, but all with the same objective: turning a large, bulky car into uniform scrap metal prepared for its next life. Once the vehicle frame has been compressed, the dense steel bundles are transported to the industrial shredder, which acts as the mechanical core of the entire recycling operation. Inside this massive machine, enormous steel shafts fitted with interlocking teeth spin in opposite directions. As the compressed block enters the chamber, the rotating blades tear it apart within seconds. The sound of grinding metal echoes through the facility as the once intact vehicle is ripped into countless fragments. In a matter of moments, a car that once filled an entire parking space is reduced to small, uniform pieces of scrap. The processing capacity of these machines is extraordinary. A modern industrial shredder can handle between 100 and 150 tons of steel every hour, which means hundreds of vehicles can be processed in a single day. This level of efficiency allows the auto recycling industry to operate on a massive scale, converting huge volumes of scrap into valuable raw material ready for melting and reuse. After the shredding stage, the mixture of metal fragments and non-metal materials moves along a sophisticated sorting line. Powerful industrial magnets quickly pull out carbon steel from the stream. At the same time, eddy current separators push lighter non-ferrous metals, such as aluminum and copper, away from the main flow. Materials that cannot be recycled into metal, including plastics, rubber, and leftover fabric, are removed and discarded. The recovered steel is then compressed into dense bundles that will later be fed into steel furnaces, while aluminum and copper are collected separately and shipped to facilities that specialize in processing those metals. From a single retired vehicle, this entire recovery process takes less than an hour to produce clean, reusable metal ready to re-enter the manufacturing cycle. What once existed as an aging car frame has now been compacted, shredded into fragments, sorted by material, and packed into standardized steel bundles. At this point, the recycling journey moves into its most dramatic stage as the metal is delivered to an electric arc furnace. Inside this enormous furnace, the scrap steel encounters extreme heat. Massive graphite electrodes release electrical currents reaching tens of thousands of amps, generating a brilliant arc that flashes like man-made lightning. Within minutes, temperatures climb beyond 1,600 degrees Celsius, heating the steel until it glows red and finally melts into a flowing pool of liquid metal. To refine the molten steel, operators add lime and other flux materials. These substances help pull impurities out of the metal, forming a floating layer of slag on the surface. Meanwhile, powerful oxygen lances burn away unwanted chemical elements. Throughout the entire process, advanced sensors and spectrographic monitoring systems continuously analyze the molten metal. These instruments ensure that the chemical composition of the alloy meets precise industrial standards. What began as a chaotic pile of worn-out car parts has now transformed into a brilliant pool of purified molten steel, ready to be poured and shaped into brand-new billets for future manufacturing. Once the steel has been fully refined, it cannot remain inside the furnace for long. The molten metal must be transferred immediately. It flows through sealed channels and enters the continuous casting system, where the next stage begins. A blazing stream of liquid steel pours into water-cooled molds. Within seconds, the outer layer begins to solidify, forming a hardened shell while the interior remains molten. Supported by a series of rollers, the glowing metal moves steadily along the casting line, cooling little by little as it travels forward. During this process, long steel billets, sometimes stretching tens of meters in length, are formed. Square billets are typically produced for construction steel, while wider slabs are prepared for rolling into flat sheets and coils. At the end of the line, automated thermal saws slice these glowing lengths into standard segments, each weighing several tons. Every billet is then labeled, scanned, and recorded into production batches. What began as a shapeless pool of molten metal has now been transformed into clearly defined blocks of steel, ready for the next stage of manufacturing. The moment these billets exit the reheating furnace, glowing bright red, they move straight into the hot rolling mill. Here, a powerful series of massive rollers continuously squeeze, stretch, and shape the steel into its final forms. With each pass through the rollers, the thick billet becomes thinner and longer. Gradually, the heavy block of steel transforms into smooth sheets or tightly wound coils. To maintain perfect accuracy, the entire operation is monitored by high-speed cameras and laser sensors. These systems measure thickness, alignment, and surface quality in real time, ensuring every strip of steel meets precise industrial standards right on the production line. The process resembles a powerful form of sculpting, where raw metal is carefully shaped with both force and precision. But freshly rolled steel cannot be shipped out immediately. First, it must cool under carefully controlled conditions. High-pressure spray nozzles cover the hot surface in a cloud of fine mist, rapidly lowering the temperature while preventing cracks or structural damage. After that, powerful industrial fans blow along the length of the coils, allowing the metal to cool gradually and maintain its internal strength and stability. Once the steel has cooled to a safe temperature, each coil undergoes a thorough inspection. Ultrasonic sensors scan for hidden cracks, high-resolution cameras check every surface detail, and mechanical testers measure tensile strength. Only the coils that pass these rigorous tests are officially stamped, logged, and sent to storage. From molten brilliance to solid, dependable strength, the steel is now ready to serve countless modern industries. What was once an old, seemingly useless car has now embarked on a completely new journey. The recycling process starts with dismantling every component, safely draining all fluids, and then putting the frame through presses exerting hundreds of tons of force. The shredded metal is sorted with incredible precision, magnets, eddy current separators, and advanced sensors separate steel, aluminum, and copper before entering the furnace, where it is reborn as pure steel. After hot rolling, controlled cooling, and inspection, the steel emerges as a clean, durable material ready for a wide range of applications, from construction projects and industrial machinery to the production of new automobiles. Every vehicle that reaches the end of its life doesn't just vanish, it fuels a multi-billion-dollar recycling industry, saves enormous amounts of energy, and reduces the pressure on natural resources. Recycling isn't just an environmental solution, it's a hidden backbone of the modern economy. So the next time you look at your car, consider this: the steel that carries you today could one day form the frame of a building, a bridge, or even a brand new vehicle. Its story doesn't end, it begins again.